Have you ever seen this? Does the ratio of 1 to 1.6 look familiar to you? Well, the screen that you're looking at right now is at a ratio of 1 to 1.6. The blue line will indicate the measure 1, while the red line will indicate the measure 1.6. To explain, we can see the blue on the left is measure 1, while the red on the right is measure 1.6. Now we'll take the blue measure 1 and place it on the red line to explain how 1.6 is measured. You can see that basically a full blue measure plus another 0.6 equals 1 to 1.6. This ratio is used in many things around you and has been used in structures for thousands of years. Here you can see the ratio of 1 to 1.6 is found in ancient building structures. This is an arena of ancient Rome. Notice how the ratio 1 to 1.6 is used to maximize the acoustics throughout the arena. Music instruments are also great examples of how the ratio is used. The keys on a piano is ratio 1 to 1.6, where the black keys represent 1 and the white keys represent 1.6 in the amount of keys. Recognize this. This ratio of increase in the circles are 1.6. The screen in the Windows logo is 1 to 1.6. The small rectangle, 1 to 1.6, and the larger picture, 1 to 1.6. The image of the Microsoft Cloud is 1 to 1.6. Notice that the red circle B is 1.6 times bigger than the blue circle, and the green circle C is 1.6 times larger than the red circle B. In these famous Van Gogh paintings, we can see the ratio of 1.16 in the division of the canvas and where the focus point is located in the painting. See, the center point of the nose, 1.16 from the side, and the eyes from the top of the painting is 1 in relation to 1.16 to the bottom of the painting. Notice how the center of the face is located at the ratio of 1.16 from the side of the canvas. In this Van Gogh painting, we see the tree, the focus point is at a ratio of 1 to 1.6. In this painting by Claude Monet, we see the tree, the focus point is at a ratio of 1 to 1.6. So, what is ratio 1.16 and where did it come from? In ancient manuscripts, we see the following. Noah's Ark is built at a ratio of 1 to 1.6. The Ark of the Covenant is built on the same ratio. So, what are these numbers? 1, 1, 2, 3, 5, 8, 13, 21, and etc., etc. The ratio is called the Fibonacci sequence because it was discovered by Fibonacci, a famous mathematician who lived from 1175 to 1250. So the ratio works like this. The next number in the sequence is the sum of the previous two numbers. So O plus 1, starting from nothing to 1, will give you 1. Then 1 plus 1 will give you 2. 1 plus 2 equals 3. 2 plus 3 equals 5. 3 plus 5 equals 8. 5 plus 8 equals 13. 8 plus 13 equals 21, and so the list continues. So here you can see another example of how it's been calculated. O plus 1 equals 1, 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, and so the list continues into infinity. It never stops. To explain how the Fibonacci spiral works, I've used a graph where each block resembles a square of 1 by 1. So we'll start with a blue block. So O plus 1 equals 1. 1 plus 1 equals 2. 1 plus 2 equals 3. 2 plus 3 equals 5. 5 plus 3, 5 plus 8 equals 13. 8 plus 13 is 21, and so on. So if we remove the lines from the graph, this is what we see. Can you see how the Fibonacci spiral is created? Here's another example of the Fibonacci circle or the Fibonacci spiral, and you can see that each block 5 by 5, 8 by 8, 13 by 13, and 21 by 21. And here's another example of a bigger ratio where it goes up to 34 and 55. And it will continue like this until infinity. There's another example of the Fibonacci spiral and how it is created. Here you can see, for example, that if we take 8, you'll see from the center point to the side, it will make a perfect quarter circle. The same with the block where 5, from there to there, will make a perfect quarter circle. So, what is this thing? 137.5 degrees. A magic number perhaps? No, but it is very significant in this talk. If we divide a circle of 360 degrees into a ratio of 1 to 1.6, then the smaller section, the blue, is 137 degrees and the red is 222.5 degrees. In here, it will resemble A in red. So what does this have to do with this plant? The angle of growth of each new leaf starts at an angle of 137.5 degrees. See the blue corner? So I had to check it out for myself. You know, seeing is believing. So I drew an angle on a paper. This is a weed. Notice the angle of the new leaf. There's 137 degrees. Then I took a leaf and stripped its flesh. What you see here is the leaf skeleton. Once again, 137.5. This is a branch from a rose bush. Notice how the new branch started out at 137 degrees. This little corner here, before it took a curve, but it still keeps the general direction of 137.5 degrees. This is a branch from a tree. The new smaller branch starts out at an angle of 137.5 before it goes astray. Amazing. Yes, but that's only the beginning. We're only getting started. So on the left, you will see that each dotted line sprouts from the center at an angle of 136.5. The one on the right is 138.5 degrees. The one in the center is called the golden angle and is 137.5 degrees. So on the left, it will be a golden angle minus 1 degree. And on the right, it will be 137 plus 1 degree. So in theory, if a line sprouts from the center at an angle of 137.5 degrees, it will look like this. So now you'll see a pattern. If the lines to the circle on the left, there are 34 lines. In the same pattern, the lines goes to the right and equals 55. Yes, you guessed it. The ratio of 34 to 55 is a ratio of 1 to 1.6. So how does this all work? And what does this have to do with the Bible? Fibonacci numbers are found everywhere in creation. An apple has 5 seeds. The number of petals on flowers are all numbers of the Fibonacci sequence. It will never be different. So here's a leaf sprouting from its stem. The second leaf will sprout at an angle of 137.5 from leaf number 1. The leaf number 3 will sprout at an angle of 137.5 from leaf number 2. Leaf number 4 will sprout at an angle of 137.5 from leaf number 5 will sprout at an angle of 137.5 degrees from leaf number 4, until it looks like this. But now you will say that they overlap anyway. So let's look at the Fibonacci spiral again. We see here a side view of the leaf growth. Here you can see that not only did the leaves grow 137.5 degrees apart from each other, but grew upwards. By doing this, each leaf has a maximum exposure to sunlight at an upward angle of growth and a maximum exposure to absorb raindrops. Here you can see the ratio of 21 to 34. This is the ratio and pattern of the florets in the center of the plant. Now let's look at this again. Now you compare the angles of 136.5 on the left and 138.5 on the right with the golden angle in the center. The one in the middle is the perfect angle for the flower to hold the maximum amount of florets. Here you'll see a succulent. Notice the spiral. Notice how the leaves grow above the previous ones in the golden angle. Trees are designed to maximize the uptake of minerals from the roots and the leaves. Tail of a chameleon. Here you can see the sequence clearly. Here you can compare the pattern of the angles with the Fibonacci angle. See the different directions of the pine cone? Yellow to the left is 13, while the green on the same cone on the right shows 8. Once again, Fibonacci numbers. So you can see that Fibonacci numbers are found everywhere. It can be found in pineapples and bananas have 3 or 5 flat sides, and pineapples scale have Fibonacci spirals in sets of 8, 13 and 21. The ratio of pineapples has been colored for your reference. This is an image of a seashell. When cut in half, it looks like this. See the relation yet? Waves go at the same angle as the Fibonacci spiral. Psalm 139 reads, I praise you because I am fearfully and wonderfully made. Your works are wonderful, I know that full well. My frame was not hidden from you when I was made in the secret place. When I was woven together in the depths of the earth, your eyes saw my unformed body. All the days ordained for me were written in your book. So if we look at this image of the human body, we see that from the navel to the top of the head is 1, and the navel to the bottom of the feet is a ratio 1.6. From the bottom of the feet to the tips of the fingers is 1, and from there to the top of the head 1.6. From the shoulder to the elbow equals 1, and from the elbow to the tips of the fingers 1.6. The hand and the forearm is a ratio of 1 to 1.6. If you look at the hand, we'll notice that each segment of the finger is 1, and the next one is a ratio of 1.6 to the first. The third one, 1.6 to the second, and the fourth, 1.6 to the third. If you look at the face, we see that from the top of the head to just above the eyebrows equals 1, and from there to the bottom of the chin, 1.6. From the bottom of the chin to the middle of the ear equals 1, and from there to the top of the head, 1.6. The upper lip to the bottom of the nose, 1, and from the upper lip to the chin, 1.6. So let's take a look at your teeth. The two front teeth you'll see is in a ratio of 1 to 1.6. The tooth next to the two front teeth equals 1, and the big teeth in the middle, 1.6. The two front teeth, in comparison to the rest of the mouth, equals 1 to 1.6. If you look at your ear, you will see the Fibonacci spiral. Your brain, Fibonacci spiral. Let's take a closer look at your lungs, shall we? First, we're going to use an angle of 137.5, but to make calculations easier, I'm going to take the remainder of 42.5. And now we look at the lungs. Remember that when we looked at the branches of the trees, of the plants, that it was 137.5 degrees. So to ease the calculation, I'm going to work with the remainder triangle of 42.5 degrees. See? And even the smaller branches of the lungs, 42.5. So it is clear that the angle that it sprouts from is 137.5 degrees. The beginning phase of an unborn baby. Now, do you recognize this? This is your heartbeat. And the perfect ratio for the heartbeat is, yes, you guessed it, 1 to 1.6. This is an example of DNA. Now, if we look at the image on the right, you'll see that on the spiral equals 1 and 1.6. 1 and 1.6. 1 and 1.6. Now, if we look at the angle at which it escalates, you want to guess? 137.5. The transcriptor activator-like effectors are DNA binding proteins secreted by phytopathogenic bacteria that interfere with native cellular functions by binding plant DNA promoters. The key elements of their architecture is a domain of tandem repeats with almost identical sequences. The top view of bound TAL along the DNA axis showing the N-terminus structure for 3-UGM. If you look at B, it shows a side view of bound TAL displayed from the N-terminus at the bottom to the C-terminus at the top, structure 3-UGM. In C at the bottom left, we can see that the TAL without DNA and the RVD is explicitly depicted laying on the inner side of the superhelix. The orange line represents the DNA axis. The protein is orientated from the N-terminus at the bottom to the C-terminus at the top. A larger pitch compared to the bound structure is clearly observable. The structure from the 3V6P protein gray and the DNA is orange. Here's another example of the DNA and the protein surrounding it. And on the right, you can see a top view of the DNA and the protein surrounding it. Does that look familiar to you? A side view of the DNA and the protein. Here you can see another example of DNA. Can you see the one on the right? Does that look familiar to you? Here's an example of DNA with the side view on the left, and if we look at that image from the top, we'll see the image on the top right. So that is basically what your DNA looks like from the top view. Now, do you remember the flowers and the florets in the center and the pattern that it does? Look at the one on the top left. Remember this? So now we take your DNA This is Hurricane Irma. Can you see the Fibonacci spiral? This is Hurricane Maria. Tropical Cyclone Harold and the Fibonacci spiral. That is the eye of a storm. Can you see the resemblance? This is a tornado. Take a careful look at the spirals and the ratio at which the spirals increase to the top. Now, I want you to compare that to this, your DNA. Here you see the Earth and the Moon. You'll see that from the center point of the Moon to the side of the Earth, exactly according to phi, which is the name of the formula of the ratio 1 to 1.618, is exactly at the angle of 137.5 degrees. Here you can see the ratio in which the planet Saturn is created. Each section is 1 to 1.6 in ratio with the next. The ratio between planets are calculated at a ratio of 1 to 1.6 from the previous one. See? 1.6. There's the Earth, right there. Here you can see where the planets in our galaxy are located. Earth is the one in the beginning of the Fibonacci circle. But this is only our galaxy. The Hubble Deep Field, an extremely long exposure of relatively empty part of the sky, provided evidence that there are about 125 billion galaxies in the observable universe. This is the galaxy Messier 94. It is in the northern constellation of hunting dogs, about 16 million light years away. Inside the bright ring of Messier, new stars are born and new stars are visible inside the ring. It is called the starburst ring. And this galaxy is also known as the Whirlpool Galaxy. There's another image of the Whirlpool Galaxy. So let's get a bit closer, shall we? If we go even closer, we can see the Fibonacci ratio. Can you see the Fibonacci spiral? Let's zoom in some more. Go a bit closer. And more. If we go even closer, we'll see the newborn stars in the ring around the center. Here's another image where you can clearly see the newborn stars in the ring. This is an image of the Whirlpool Galaxy from the Hubble telescope on the left. And on the right is what we see from the ground if you look through a telescope. And if you go even closer, right in the middle of the Whirlpool Galaxy, in the center of the black hole, is this light. And if you take a closer look, then this is what we see. In the beginning was the Word, and the Word was with God, and the Word was God. He was with God in the beginning. Through him all things were made. Without him nothing was made that has been made. In him was life, and that life was the light of all mankind. The light shines in the darkness, and the darkness has not overcome it. So God gave us a symbol of the cross, 16 million light years away in the whirlpool galaxy where stars are born, where stars are created. My theory, right where the universe started creation, Yahweh left a sign that said that one day Jesus will die on the cross for us. He knew. When God spoke and said, "Let there be light," it had to start somewhere. And it was not the Big Bang theory of Darwin. It started right here in the center of the whirlpool galaxy, where God left us a sign of the cross even before the earth was created. The DNA of Yahweh runs through his son Jesus, and everything was made through Jesus. Nothing that has been made was made without Jesus. It is clear that Yahweh the Father's DNA runs through Yahweh the Son, Yeshua, into everything in creation. When the symbol is left for us in the center of the star-forming galaxy is where the first Fibonacci spiral started, right from the hand of Yahweh the Son, Yeshua. From there, his DNA, Yahweh's DNA through his Son, spread throughout the whole creation. Everything started when Yahweh said, "Let there be light." And the light originated from the center of the whirlpool galaxy and spiraled throughout creation.